Welcome, we are back. Let's move now. We are going to more marks now, calculations involving Kc. We'll start very slow and very low so that everyone can understand how do we deal with the Kc story. Now before we do that, let me just explain this one of Le Chatelet's principle and Kc values and temperature. At Kc is 2.1 at 400 degrees, and then Kc is 0.21 at 500 kelvins. They say use Le Chatelet's principle to explain. 4 marks. We're going to now, firstly, we say we block one. We use either we start with temperature or start with Kc, but don't mix the two. So we start with this one to say from 2.1 to 0.21, therefore Kc is decreasing. Ne? Therefore, decrease in Kc. Tell the examiner now, decrease in Kc value implies that more reactants produced and less products, or the concentration of the reactants is greater than that of the products. Therefore, according to that one, it means that now the reverse reaction is favored. Reverse reaction is favored. That's the is favored. Second mark. Now we go to temperature now. From 400 to 500, what happens? The temperature is increasing. Principle says increase in temperature. Increase in temperature favors an endothermic reaction. Thermic reaction. In any reaction, increase in temperature favors endothermic reaction. Therefore, according to this one, reverse is endothermic. Reverse reaction is endothermic. Then the forward is exothermic. That will be the 4-mark question, asking you to say if your Kc is this 2.1 at 400 and is 0.21 at 500, is the forward reaction exothermic or endothermic? You can start now. Fine. Increase in temperature is favoring the reverse, therefore forward is endothermic, and then you explain. That will be the case. Now let's come to the simple calculation of Kc. We are given this one to say carbon dioxide and hydrogen in equilibrium forms. Then you are asked here to calculate the Kc. What do you do first? Again, this one they said equilibrium concentration of carbon dioxide, water, carbon monoxide, and this, because all of them will be now in the Kc expression because they are all gases. These are gases equilibrium. All substances will be involved. Then you just start by writing the Kc expression for this. Product is carbon monoxide multiplied by water. Remember, we say we exclude water only if in the form of a liquid and solid, but we don't exclude it if it's a gas. So then this will be the Kc expression. Get 1 mark. Substitute in the Kc expression. This is a Kc expression. You substitute. Carbon monoxide is 3, and then hydrogen water is 7.2, and then carbon dioxide is 2,4, and then hydrogen is 4.5. These values are given. They are here to say carbon dioxide, it's a reactant, product, and then product reactant. So that's the case. Then you just slot in the values, and you can put brackets if you want to. It's not an issue. Then your final answer will be 2, the high Kc value. That's the case. So That is when we calculate the Kc value now. And the next one, let's say for example they give you sulfur dioxide, to say 2 sulfur dioxide gas plus, yeah, sorry for the glitch. We are given this sulfur dioxide, nitrogen dioxide, and then sulfur, this is not 2, sorry, sulfur dioxide, where do I get the 2, and then gas plus nitrogen oxide gas. They are all in the equilibrium. In this case, this is sulfur trioxide, the other one is sulfur dioxide. Yeah, thank you, it's fine. Sulfur dioxide forming sulfur trioxide. Now, according to this one, they say at certain temperature, now it is found that the concentration of sulfur dioxide is said to be 0.25, and then concentration of sulfur trioxide is said to be 0.5, and concentration of NO2 is said to be 0.2, and then concentration of nitrogen oxide, so nitrogen oxide is said to be 0.3. They say find the Kc value. This one is at equilibrium, at a certain equilibrium, at certain temperature, then this was found. So what we need for 4 marks, we need just to write the Kc expression for this. You can see now the products are 2, they are both gases, therefore it will be sulfur trioxide multiplied by NO. This equation is balanced. Remember, in all cases you'll be given balanced equation. You don't have to struggle to balance equation, they will be balanced for you. And then nitrogen dioxide, then from there you substitute, then you get sulfur dioxide. Sulfur trioxide is 0.5 multiplied by nitrogen oxide is 0.3 divided by sulfur dioxide is 0.25 multiplied by nitrogen dioxide is 0.2. The answer, if you use your calculator, must give you somewhere around 3, which is also high Kc value. Let's go to the one that is much better. Now, where we're supposed to now draw a table, I hope, so that you can learn at least the table method in a way. Now, let's say in this one, they're giving us this, to say the 2 sulfur dioxide, the well-known one, involved in the contact process, and then the sulfur dioxide forming sulfur trioxide gas. Now they are telling us to say 8 moles of sulfur dioxide react with 10 moles of oxygen in a 500 decimeter cubic centimeter volume container, a vessel in this case. Now remember that we are not dealing with the cubic centimeters, we are dealing with the decimeter cube. We must quickly just convert this one to 0.5 dm cube. Fine. And then at equilibrium, it is found that we have got 6 moles of sulfur dioxide. Sulfur trioxide was found. Then they say now for 7 marks find the Kc value. This is 7 marks. Now what do we do first? We'll have to now copy the equation again. Sulfur dioxide in our answer plus oxygen forming sulfur trioxide, 2 sulfur trioxide. What do we do as the best method? We are going to use the mole method. There are two methods of finding Kc, is the mole and the concentration. The best one is the mole method. We now draw 5 lines. Draw 5 lines below the equilibrium reaction. 5 lines. That will be enough. Each substance must have its own column. And then on the left hand side here, you just show us which method you are using. You are just using moles now. We just say initial moles, change in moles, moles at equilibrium, and concentration at equilibrium. This will be sufficing for this one. In the table, we are gunning for 4 marks. Yes, this one, the delta is using the mole ratio as given here, 2:1:2. We're going to use that. When we start, we are told that we have got 8 moles. 8 moles of sulfur dioxide and 10 moles of oxygen. Nothing is said about the reactant, the products. We assume that we don't have any product when we start. At equilibrium, we are told that we have got 6 moles of the product. Fine. Then we start where we know most, because this one we don't know 2, then this one we don't know this one. If we start with 0, we don't know how much we produce, but we end up with 6. Therefore, it means that now we have produced 6 moles. Then produced, people are putting negatives and positives for just as a way of making it easier to work with this. If we produce products, then there will be plus, the reactants will be negative, negative. Fine. But we are using the ratio here. Ratio says 2:1:2. 2:2. If this one is 6, this will be 6. If this one is 2:1, this one will be obviously 3. Therefore, if we started with 8, subtract 6, therefore we'll end up with 2. If this one 10 minus 3 we'll end up with 7. Then at equilibrium, now we divide by volume. Remember, concentration here, we are using the formula C equals to N over V. Then it means that now 2 divided by half, 2 divided by 0.5 give us 4. 7 divided by 0.5 give us 14. 6 divided by 0.5 is give us 12. This is the concentrations at equilibrium. What we do, we write the Kc expression. According to this one, they are all gases. If they are all gases, mean that they are there in the equilibrium expression. Therefore, product will be sulfur trioxide squared divided by sulfur dioxide squared multiplied by oxygen. If we substitute, we will get sulfur trioxide squared is 12 squared divided by 4 squared multiplied by 14. Use your calculator in this case just to confirm the answer, to say if you work out this one with your calculator, you will end up with an answer that should be found by anyone using this. This one will give you 0.64. That's when you use your calculator, you get 0.64. So the best method of finding the Kc, especially when you're drawing a table, the table method. In the table method, remember, it's 4 marks. 1 mark for the change in products. Fine. 1 mark for the change in both reactants. 1 mark. 1 mark for the usage of the mole ratio. And 1 mark for dividing any moles that you find at equilibrium by the volume. You get 4 marks. 1 mark for the Kc expression, 1 mark for the substitution, 1 mark for the answer. Therefore, you get 7 out of 7. So we'll try and do exam type questions using this method and then so that you will master it as we continue. Thanks a lot. Until we meet again in the next sessions. Bye.